In this lesson, we are going to learn some basic rules of integration. The first one, integrate of 1 with respect to x is equal to x plus c. We also can refer to the rules of when we integrate a constant, let's say constant a with respect to x is equal to ax plus c. So constants, you can refer to real numbers, where real numbers consist of rational numbers, q, and irrational numbers. So for rational numbers, like if in number line, these are all rational numbers, 0, 1, 2, or let's say fraction 3 over 2. It also includes -1, -2, or let's say -3 over 2. These are all constant. For example, when we integrate 2 with respect to x is equal to 2x plus c. When we integrate a constant 3 over 2 is 3 over 2x plus c. These are all constant, but don't forget the constants from irrational numbers like e, pi, sub2, and etc. For example, integrate a constant e with respect to x is equal to ex plus c. Integrate pi with respect to x is equal to pi x plus c. Integrate sub2 with respect to x is equal to sub2x plus c. The second rule, integrate of a linear function x raised to power n is equals to x. We increase the power by 1, n plus 1, and divide by n plus 1 plus a constant, provided n is never equals to -1. For instance, rule number 2, we integrate, let's say x power 4 with respect to x. When we integrate, we increase the power by 1. So we have x power 5 and then divide by 5 plus c. Actually, rule 2 is same with the fifth rule. Integrate of a linear function. I would like to highlight here, this function must be a linear. And then n never equals to -1. So the result is ax plus b raised to power n plus 1 divided by a times n plus 1 plus c. Where this a come from? This a is the differentiation of ax plus b. For example, the fifth rule, integrate a linear function, must be a linear, like 1 plus 2x raised to power 4 with respect to x is equals to 1 plus 2x. Then increase the power by 1 is 5, divide by 5. And then at the same time, we differentiate the linear function 1 plus 2x is equals to 2 plus c. Sometimes students might overuse or misuse this rule. For example, integrate of a quadratic function raised to power 2. Do take note here, this is not a linear, it's a non-linear function. It's called as quadratic. we cannot apply this rule. This rule strictly for linear only. So what we do for this case, we should expand first. Expand first. Expand the squared. We have 1 plus 2x squared plus x power 4 with respect to x. Then we integrate. Okay. Then why this rule exclude n is negative 1? Okay, what happened? What if n is negative 1? For example, 1 plus x raised to power negative 1 with respect to x. If we apply this rule, what will happen is we increase the power by 1, so negative 1 plus 1 is 0, and divide by n plus 1, actually, sorry, this is 1. Negative 1 plus 1 is 0. We divide by negative 1 plus 1, which this fraction, this whole fraction is undefined. And if numbers divided by 0 is undefined, therefore, this rule cannot apply when n is negative 1. The third rule is involve constant. If a constant times a fx, we can pull out the constant and then integrate the fx. For example, integrate 2 sub x. First, pull out 2. X is x 1 over 2 with respect to x. So 2 remain 2. Half plus 1 divide by half plus 1 plus c. Let's carry on. Half plus 1 is 3 over 2 divided by 3 over 2 plus c, where is equals to 4 divided by 3, x raised to power 3 over 2 plus a constant c. The fourth rule, integral involve fx plus minus gx. We can integrate separately. Integrate fx first, then followed by plus minus integrate gx. For example, the fourth rule, integrate sub x plus x squared is equals to integrate sub x with respect to x plus integrate of x squared with respect to x. We can integrate it separately.